Okay, this is still standard 20, and we're going to be looking at these tables to figure them out because they're going to be on the assessment. So let's look at this one. This says geologic timescale. So whenever you have a table, you just kind of explore it first. So across the top, we have the words eon, era, period, epoch. And those represent these columns. So all these words in the eon column are these words, names. These are eons. So Phanerozoic is the eon that we're in right now, in the present. And then the other eon that has been recorded is the Precambrian eon. And within an eon, at least this present one, we have 3 eras. We have the Paleozoic, Mesozoic, and the Cenozoic eras. And then within each era are a number of periods. So in the Cenozoic era, we have the Quaternary period and the Tertiary period. And it looks like they've also divided the Tertiary into 2 periods, which is, you can't maybe read that, and neither can I, but yeah. Okay, so then the Mesozoic era has 3 periods, the Cretaceous, the Jurassic, and the Triassic. And then these periods have epochs within them. So the Quaternary period has Holocene and Pleistocene epochs. So the other thing that we need to understand, I'm going to sneeze. Okay. The other thing we need to understand is the timeline here that they have. It says age in millions of years before the present. So up at the top we have 0.01 million years. The next is 1.6 million years, 5.3 million years, and so on. So let's look at this table, and we need to sync it up with this table to get information. So this table has, we'll look at the top row. It says fossil, and then picture, and then time period. So these are the fossils that are found only in these time periods. So the Parasphinctus, for example, is only found in the Jurassic time period. So if we find a fossil in a rock layer, and we also find Parasphinctus in that rock layer, the Parasphinctus acts as a fossil index that gives us information that the fossil we just found, the other fossil, is of the Jurassic period. So over here, if we look at the time frame for the Jurassic period, we can also know when we could date that fossil. So it's between 144 and 208 million years ago that fossil can be dated to. And if there are other fossils, we can see all of them that are part of that Jurassic period. So that's how you read those 2 tables. This next diagram is talking about superposition. So we learned this way back when we studied the Grand Canyon, that the layers on the bottom are older than the layers on the top. So this is sedimentary rock, and we know that is formed through weathering and erosion, through sedimentation, deposition, and cementation. And so that over time, over millions of years, dust and particles and different pieces of rock are all they're eroded first, and then they are deposited into a low-lying place, and then they're compacted or cemented over many millions of years to create the hard sedimentary rock. So the ones on the bottom, that happens first, And then the subsequent layers happen later and later in time. So this is called, the concept is called superposition. And so in this question, the question's about this image that you're seeing, you're going to be asked about which layer is older and which layer is younger. So we know the top layers are younger and the bottom layers are older. And the rest are in that order from oldest to youngest, bottom to top. Okay. Next up, we've got this going to be similar question. We've got various layers, and you are going to have to determine which layer is younger and which layer is older than the other. That's called superposition again. Okay, and this question that uses this picture, we are seeing that the dinosaurs only lived during the Mesozoic era. And so if we flip back up to this chart, the dinosaurs only, they started to exist in the Triassic period, and then they were fully in existence during the Jurassic and the Cretaceous period. They died out 66.4 million years ago. And so by the time we got to the Tertiary period, there were no more dinosaurs left on the earth. And that's 66.4 billion years ago. So they were only in that time frame. And so when we talk about fossils, look at all these different kinds of fossils from all the other eras and periods. The dinosaurs were only right here. I think this is the woolly mammoth, because it's in the Cenozoic period, which, let's just look back up here. The Cenozoic is not the period, the Cenozoic era. That the dinosaurs weren't a part of that era. So, but we had, I don't know if they consider the woolly mammoth not a dinosaur, but the point is that there are lots of different organisms besides dinosaurs that we find as fossils, not just dinosaur bones. These are just the most, what's the word? They're just huge organisms, and we don't have those types of organisms on Earth anymore. So we just, scientists, paleontologists, we think it's really cool. So we focus on that. But there are lots of other fossils that we find in other layers of the Earth. And I mean, check out all these layers, right? It's kind of cool. So the rock types and the rock layers, these are the newest rocks. So superposition here too. And here's the oldest rocks. And we find these fossils in these oldest rocks that date way back, way, way, way back. So you need to understand that dinosaurs and fossils, they aren't synonyms. Fossils are include all of these things, and dinosaurs are just one type of fossil that they find, the dinosaur bones. Okay, so again, this is a superposition question. In addition to the fossil index, we see that this is the pattern of this layer, and they found these types of fossils in this layer, and this is one archaeological site that they found these layers in the different fossils in each of these layers. And so this is another archaeological site, and they have found these in these layers. So you just need to compare this to see if there are some similarities. This right here is kind of crazy because this is it says up here intrusion. It's an intrusion. So that is intrusive igneous rock from a volcano. And that's going to be the youngest layer of at least these three layers. because these 3 layers already existed before this thing poked its little finger up into there, meaning the the underground flow of lava and a little volcanic fissure right here comes up. It doesn't come up all the way to this layer, so it's possible that it would have come up just to that point, and then this layer could have happened afterwards. So we're not sure exactly of the time between this this magma that cooled over time in between these layers and this top layer. We're not sure which one comes first, but we know for sure that these layers are older than this because this lava pushes up between those layers that were already formed before it pushed up into it. So that's what we need to understand about that. And that is it for that assessment. I wish you luck.